What would happen if a truly massive asteroid slammed into the Sun? You might think, the Sun is huge, an asteroid is tiny. What's the big deal? But what if I told you the consequences could be far more spectacular and dramatic than you could ever imagine? Let's dive into one of the most extreme cosmic collisions possible. The Sun is the undisputed king of our solar system. It's a colossal ball of plasma, so massive it contains 99.8% of all the mass in the entire system. Its energy output is staggering, a constant nuclear furnace that bathes all the planets, including ours, in life-giving light and heat. But what happens when you throw a giant space rock into that furnace? The idea isn't pure science fiction. Asteroids, these ancient leftovers from the birth of our solar system, are constantly zipping around. Sometimes, the gravitational dance of the planets can knock one off its course, sending it on a one-way trip straight into the heart of our solar system. Scientists have been running the numbers and creating complex simulations to figure out what would happen. The answer, it turns out, depends on a few crucial things. How big is the asteroid, and what's it made of? So, let's set the stage. Imagine an asteroid, not a small pebble, but a behemoth several kilometers wide, hurtling through space. As it gets closer to the Sun, the sheer gravitational pull becomes immense. The asteroid accelerates to mind-boggling speeds, hundreds of kilometers per second. Even before it hits, the Sun's intense heat starts to take its toll. The side facing the Sun would begin to glow, then melt, then vaporize, creating a brilliant tale of superheated gas and rock, like a comet on steroids. Now for the moment of impact. The asteroid wouldn't just plop into the Sun like a rock into a pond. It would slam into the Sun's surface, the photosphere, with unimaginable force. The kinetic energy released in that single moment would be colossal, dwarfing the combined power of all the nuclear weapons on Earth by many, many orders of magnitude. This impact would create an explosive event of epic proportions. The initial flash would be blindingly bright, a cosmic firework that could temporarily outshine a small portion of the Sun itself. This isn't just a simple explosion, it's a hypervelocity impact into a sea of plasma. The asteroid's material, now completely vaporized and ionized, would mix with the Sun's own plasma, creating a massive, expanding bubble of superheated gas. This bubble would rise rapidly through the Sun's outer layers, triggering a solar flare on a scale we've never witnessed before. A normal, powerful solar flare can already release vast amounts of energy, but one triggered by a massive asteroid impact. We're talking about a hyperflare. This event would unleash a torrent of X-rays and high-energy particles into space. If this flare were pointed towards Earth, it would be bad news. It could overwhelm our planet's magnetic field, potentially crippling satellites, causing widespread blackouts, and posing a significant risk to astronauts in orbit. But the show doesn't stop there. The impact's shockwave would ripple through the Sun's plasma, not just on the surface, but deep into its interior. Think of it like a seismic wave, but traveling through a star. This sunquake could disrupt the delicate balance of the convective currents beneath the surface, the massive, rolling cells of hot gas that carry energy from the Sun's core to its surface. This disruption could have lingering effects. The impact site would become a region of intense magnetic activity. For days, weeks, or even longer, this area could be a hotbed for further solar flares and other eruptions. The Sun's magnetic field lines, normally complex but somewhat orderly, could become twisted and tangled by the impact's violence. When these tangled magnetic lines snap and reconnect, they release energy in what we call a coronal mass ejection, or CME. An impact-induced CME would be a monster. A colossal cloud of magnetized plasma, potentially weighing billions of tons, would be blasted out from the sun at millions of kilometers per hour. If this cloud were to hit Earth, the effects would be catastrophic. It would trigger a geomagnetic storm so intense it would make historical events like the Carrington event of 1859 look like a minor squall. Our power grids would be at extreme risk of collapse. Communications would be disrupted globally. The beautiful auroras we see at the poles would be visible all over the world, a beautiful but terrifying sign of our technological civilization being pushed to the brink. Now, let's consider the asteroid's composition. A rocky asteroid would vaporize violently. But what about a dense, metallic one, made mostly of iron and nickel? It might penetrate deeper into the sun before completely disintegrating, delivering its energy to a lower layer. This could potentially trigger an even more profound disturbance within the sun's convective zone. An icy asteroid, essentially a giant dirty snowball, would vaporize very quickly. But the sudden injection of water and other volatiles could create its own unique chemical and energetic signature in the sun's atmosphere. Computer simulations are our best tool for exploring these scenarios. Scientists input the variables: asteroid size, speed, composition, angle of impact. Let supercomputers churn through the complex physics. These models show us the initial flash, the expanding fireball, the powerful shockwaves, and the subsequent magnetic chaos. While they are incredibly sophisticated, there are still uncertainties. The exact behavior of plasma under such extreme conditions is at the cutting edge of physics, and the sun still holds many mysteries. So, would an asteroid impact kill the sun? Absolutely not. The sun is so mind-bogglingly massive that even the largest asteroid in the solar system would be like a grain of sand hitting a battleship. The sun's core, where nuclear fusion happens, would be completely unaffected. The sun would continue to burn for another 5 billion years. The real story isn't about destroying the sun, but about triggering its immense power in a violent, unpredictable way. The impact acts as a cosmic detonator, unleashing the sun's own stored energy in a focused, cataclysmic event. The sun would heal, the ripples would eventually fade, and the impact scar would be swallowed by the constant churning of its surface. But for a short time, from days to weeks, the sun would be a much angrier, more violent star. And for any civilization in the firing line, that short time could change everything. It's a humbling thought experiment. It reminds us that we live in a dynamic, sometimes violent solar system. While the odds of a massive asteroid hitting the sun in our lifetime are incredibly low, studying these possibilities helps us understand the immense forces that govern our cosmic neighborhood. It pushes our knowledge of astrophysics and helps us better appreciate the relatively stable and predictable star we depend on every single day. What do you think is the most fascinating part of this cosmic collision? Would you be more worried about the initial flare or the monster CME that follows? Let me know your thoughts down in the comments. If you enjoyed this journey into cosmic chaos, please give this video a thumbs up and subscribe for more deep dives into the wonders and dangers of space. Thanks for watching, and I'll see you in the next one. Please hit that like and subscribe button for more wonders and dangers of space,